I'm a research engineer. I have a number of inventions. So to see what we could do with the brilliant minds that we have here. Also, on the side, to develop a nucleus of engineers who are trained so uniquely that they become very valuable in a very short time. So with Dr. Hamparian, and hopefully in the future, if successful, we would see if it would be possible to promote master's and a PhD program in Armenia. Master's degree is very important because worldwide no country offers it. I'm a professor, visiting professor, supposed because they don't pay me, they call me distinguished professor or emeritus professor. I go to India, I give lectures and so forth, etc. But I am convinced that with today's expansion and explosion of solar power technologies, power generation, we don't have a single engineering professional who understands A to Z, holistics of what it is to design something that works. And the last day I'll show you some of the issues, critical issues associated with solar power systems. Today's solar power system, nutshell, could be compared to the early days of automotive industry. You could go and buy an engine, but not the chassis. You will buy the chassis from somewhere else. You could put whatever, carrossery or carriage that you want. You have no dashboard. You have just a pedal, and it even doesn't show how much gas you have. And you crank it. Today, solar energy is at that stage. But we have technology solutions that transforms and brings it instantly into the computer age. That kind of a disruptive technology, this is what I'm hoping to develop in.
But it's been 4 or 5 years I've been coming, trying to recruit PhD students that would go with full scholarship to a state university in New York where they have smart power, $75 million being spent, etc. And they promised me yet, and they'll stipend, and of course they want that to research and study. My thing is that we don't have the cadres. It's good to get those people to get the PhDs and whatnot, but you need the people who will train them, who will teach them, but we don't have that. That has died over the 25 years. It has gone to zero. We need to train the trainers first before we train the students first. But I haven't been successful finding the students interested in taking that offer.
Yeah, let me tell you quite frankly, I have been a lecturer, I've held international symposiums and so forth, and I have a fairly good understanding of which countries they really produce fundamentally good engineers. One of the best countries that produce fundamentally very good engineers, obviously, there's not to say, is Germany. They have a different approach. But even Germany doesn't have the technology foundations for offering master's and PhD programs. They don't. India has perhaps one of the most stringent theoretical graduates ever. When you graduate from Indian Institute of Technology, automatically you go to MIT and so forth.
If you're refused by MIT, you can go to MIT if you're refused by the Indian Institute of Technology.
But you see, again, when you go to MIT, you come out, you're still useless. Because you're not pragmatic. Yeah. Essentially, 90% of what you learn in university, you forget. Once you really end up on the working channel, that's where you develop your profession. Universities as a whole are institutions to give you tools. Once you have the tools, if you don't use them properly, most of the tools are going to be useless. So essentially, the issue of really whether you have a fundamentally pragmatic, strong educational program, it doesn't mean a thing which country you are from, or whether it's New York University, whether it's Harvard or whatever. Quite frankly, there is no monopoly in terms of intelligence anywhere. You could take an African pygmy and train them to be professors, because the modern human brain all needs to be is direction and directive. Incidentally, I've written a book for education. It really fundamentally says how human beings learn. It's called Education as an Intellectual Development and a National Policy. It really covers the entire neuro-physio-dynamics of human thinking. Because today, essentially, when you train wonderful people in one classroom, you may have some bright guys and so forth, and some not so bright guys. It may turn out, depending as to what situation you have, the not so bright average guys perform much better in life than the very bright guys. So essentially, the idea when we are suggesting institution of a program where you could train master's degree or a PhD program, it really is, from my perspective, is uniqueness of what this new discipline will provide. I'm a very practical person. I'm also very good at theoretical physics and so forth. But to me, you don't earn money by being a theoretical physicist. You don't. You go and work for NASA or whatever it is, but you could really become extremely useful contributing to the national economy, GNP, if you know how to build things, how to design things, and so forth. So essentially, the idea is really to produce a grade, or shall we say, class of technologists who are extremely pragmatic. How could you do that is really harvest some of the brilliant brains who are wondering what to do. Take them, put them in under a stringent, shall we say, educational program where in a year, year and a half's time, they would come out and they would be available to really contribute directly to. Anyway, any other?
Just kind of automatically, we entered the question and answer session. If you are not against, we can continue like that a few moments.
Okay.
Yes, doctor. Just to follow that subject that you were talking about, the gentleman, I don't know how many people are familiar with XPRIZE that you may know, I'm sure. So many things have been done around the world. SpaceX was an XPRIZE project, meaning you reward or you put a prize, a gift at the end of the project. I think Armenia, with your project, with this idea symposium, maybe next year, the year after, could be in Yerevan to put an XPRIZE. That means
so loud I can't hear.
Okay. All right. I don't know if it's working again. So in other words, put a prize to bring all the brains, probably all the Armenians who are with you in this kind of a, let's say, idea of reaching something. A lot of new innovations have come from XPRIZE. The other thing I was going to mention was that with the Morse law, that you're very much familiar, now the technology for the last 20, 30, 40 years, it changes, doubles every 12 to 18 months, the capacity of every electronics or in computer. So the solar system is projected to, to double the efficiency around the world every 12 to 18 months. So within next 5, 10 years, we could have a much more efficient solar systems. Do you agree with that or not?
Let me tell you something. Human resource development very much depends as to what intellectual regime you're exercising. When I made a reference to the fact that one of the ideas that I have, hopefully, is really to put together a research center. The research center would not be just collection of people who are brilliant, you bring them and so forth. I personally, by nature, I'm an inventor. I solve problems and so forth. I have stacks of technologies. The issue is the ideas don't produce any results unless you really have supportive mechanism. investment and so forth. I have disruptive technologies. I don't want to BS you guys. They're disruptive technology. It changes the entire solar power system on its head. I have prototypes working, and so I'm at this juncture that I say I need $10 million to really productize it. The offshoot of it is a billion-dollar industry. Every solar panel manufacturer in the world will be transformed completely. It's a cloud-based system, Zigbee system, and so forth. I'll go on and on. I worked 10 years on it. And essentially what happens, I'm stuck with it, all right? So I've spent $250,000. Now I need that money to really... Armenia is a wonderful place. Here we have brilliant educational system, mostly in software. There's a lot of IT guys that are coming out. But the issue is the substance of the people. I see, you know, today I was with a gentleman who's a philanthropist. He came here. They were taking a picture of the students in cafeteria. They were overjoyed. Artak, you remember? You know, I'm like that when I look at the grand educated people. Last time I came, I was surrounded by no less than 20, 30 PhD students. And I'm asking them, what are you doing? One of them says, I'm a theoretical physicist. And I'm saying, what the hell are you doing? Teaching at a grade school. He says, I don't have an opportunity. I teach at the university a few hours and here and there. It just burned me up. The guy is a PhD. Well, quite honestly, the PhD degree here and in States, there are quite a differences. But the issue is the substance of the guys. These are the guys that, quite honestly, are brilliant with all the hardship and the conditions that we've got. Some of them, they said, I got my PhD because I had to go to Army. What an answer. I mean, you have to go to Army to serve, you go to a university, you get PhD, and you come out and do what? You have elevated yourself, and then you go through a depression. So essentially, I talk to guys who are software programmers, chip designers, you name it, over and over and again. I'm looking at these guys, my God, I wish I had these guys in the United States. I could have had this product up and running 5 years ago. It's not still too late. My vision is that if I could somehow contribute to this country, I don't care about IP or so forth, what am I going to do with umpteen inventions that I've got? I've got medical inventions. I've got all sorts of crazy stuff. I have intelligent lives that they think and so forth. What do I do with these things? I sit on them and wait for investors to come? No. This is really a hotbed that you could take the people, train them. I'm a type of a guy that more or less, I'm a one-man band. I do everything, I plan everything. So if I had the technical assistance and enthusiasm that could be generated, it's in a short period of time, it's possible to really come up with products that are not intended for native distribution. You could take them, label them, and say it's made in Switzerland. Who cares? So as long as you manufacture here and it's produced here, what I'm looking at, how could you really tackle the industrial, shall we say, germination? There are lots of enthusiastic people, well-wishers, devoted Armenians, also very affluent Armenians. They are in Russia, they're in the United States. Why not show them that we can? Why not show them that we have not lost our innate Armenian creativity? That is truly what I am looking forward, and I hope that the medium of the Armenian society, they realize that no man can do things by themselves. You may have all the best wishes and energies and enthusiasm, but if you do not get support, nothing will happen. So essentially, that is the main objective. I'm so enthusiastic to have found wonderful friends and great thinkers like Dr. Hamparian. He's been struggling alone, and I'm hoping that together and other associates, we could really do something very viable.
Well, that amount that you mentioned, $10 million, to be honest with you, should not be very difficult within a short time. Within the Armenians that we know, most of the names we should have.
Come and join the group.
Oh, no, I'm just saying it should be very easy. Honestly, I'm not being, making bragging about it, but that should be, if that could be a starting point for here to do that, within a few people that we have the names, it could be done. We'll talk later.
Wonderful.
This is nothing.
Glad.
Thank you. Any more questions and any kind of questions, please? No?
Ova hajur kaj mega. Oh.
Yeah, okay.
Aref, how do you evaluate the cost effectiveness of using solar trackers in your design, usually?
Pardon me?
Solar trackers in your designs. How cost effective are they for you?
Look, anything that concerns solar power system design, it's very, very important that you understand the holistics of the whole thing, A to Z, because as an engineer, when you say, I'm going to do solar power design, it just depends at what level you're standing, okay? What distinguishes the value of of an engineer, I don't care what discipline you are in, is what is the profundity, the depth of your understanding of entire issues, not just, okay, yeah, I could do single line diagrams and so forth. In the United States, I've seen designs. I wouldn't even hire the guy to be a janitor, let's put it this way. Solar power designs, the problem with solar power system is that from the outside, it is super simple. Experience says anything that it looks very simple is not. Absolutely. Anything that looks very simple is not. And solar power is a wonderful example of it because, as I said, I'm just touching the superficie of it. Quite frankly, I've spent 25 years, I've set up a very important engineering organization. I have deviated doing a lot of solar power system because the reason for that is there aren't any. So I'm a high-priced engineer specializing in science. I'm looking, it shouldn't be that way. There is a mechanism, there's a curriculum that I've written 9 books and so forth. A to Z of anything that you want is there. Why not create this discipline that really will give out not only just engineers, but graduate engineers? There's a difference. When you're going to an engineering school, you graduate, you even don't know who you are. It takes about 5 years to find yourself, yeah, I'm an engineer, I'm specializing in something. That's normal. Whether you're a medical doctor and so forth, it takes seasoning. Once you're really entrenched, you're done, okay? So essentially, this is a technology that is unlike anything that has come up. So it is a technology that requires a fundamental knowledge of multiple disciplines. And essentially, when I start talking tomorrow, there are 7 stages, 7 pillars of really A to Z of solar power. And it means that you really have to have mature people really having the fundamentals of basic knowledge in physics, in chemistry, in electrical engineering, electronics engineering, some software and so forth. So where do I find these people? They would be only the ones who really graduate. And I don't care whether they're civil engineer and so forth, because it's possible to really boil down and make them understand the analogies of what is an electronic circuit. I could make an analogy with water system. But essentially, the whole thing is you take this, shall we say, seasoned educational graduates, train them specifically in a discipline that does not exist anywhere. If you ever have a university that says, we are a credible institution, we have graduated master's degree in engineering, the discipline has been developed by someone who knows what he's doing. Can you imagine how many employment offers you would get from states, from Germany and so forth? So essentially that's what it is.
Yeah, I also have a question. It is about the optimizers, because if we are talking about the rooftop systems, they are very frequently surrounded by other buildings and making shade or some kind of probably trees are there. So what is the, I don't think that too many people are just aware of the optimizers in Armenia.
Actually, when you're doing solar power system design, there are 7 stages to it. Stage 1 is really evaluating all issues associated with what we call solar power platform, whether it's a rooftop or ground mount. What you want to do is, first of all, you have to be very well seasoned, understand what parameters affect solar power production. That's optimization. And what tools do you have to use to really do a preliminary assessment? For that, the initiation of the solar power design starts with what we call feasibility study. Feasibility study requires that person or individual who are doing feasibility study, they have a wide spectrum of knowledge from environmental sciences to economics. Essentially what feasibility study does, whether it's not necessarily residential, but whatever, it's a rooftop, trellis, even residential, multiple residential or industrial, the issue is you have to understand the solar physics of the region. You have to be very much aware of the solar irradiance map. You have to have the proper instruments to be able to really do what we call shading analysis. Because if you go somewhere and let's say in 2 kilometers there's a hill, you have to be mindful that in different seasons of the year, sun rises at certain angle, and if you have the hill, it's going to cast shadow. If you have a lake nearby, and during the, let's say, June, that lake is going to create reflection. So that reflection is not a small issue. It could increase the solar power considerably. So essentially, there are lots of other issues. There are environmental factors. For example, the moment you go to a location, you want to put solar power on the ground, it changes the environment. Essentially, what you're doing is you're casting a shadow, you're creating a shadow, and all of a sudden, the place where you had no grass, there's grass starts growing, and you have creatures like rodents and so forth. They love chewing electrical wires. They just enjoy. So essentially what you have to do, you have to take that in consideration. The other thing is, okay, I'm installing this place. What is the environmental situation? How much rain do I have? Is there any lightning? The other thing is, what is the ground resistance? There are so many engineering and physical scientific issues. If it's a roof mount, you have to look at, okay, first of all, how is the roof constructed? Is it appropriate to install solar? Is it facing north-south or something? What is the weight that the joists and beams can carry? If it's flat, you'd like to find out the type of installation that is required to secure the solar modules. In some buildings where you have a concrete or light concrete weight, there are special ballast systems that you don't have to drill. In some instances where you have a concrete, you have what we call a penetrating type. And in some instances, you have a wooden roof. How do you go about putting solar power on wooden roofs? So you have to be mindful of structural issues. You look at the beams and see if you have to strengthen the trusses. If not, what are you going to do to really lay special planks so that the load of the solar power system gets distributed across? So you're an electrical engineer, you think you could do solar, you better be a structural engineer too. If you're not very certain of what you're doing, have an associate who could evaluate. The other thing is, you put solar power on a roof, what does it do when it rains? What kind of leakage you could have? Or what kind of a water diversion you have to have? You see, I'm looking at Yerevan. The roofs are absolutely inappropriate. They're metal roofs. You cannot put anything on metal because when metal gets hot, it affects the temperature of the solar cell and it loses. So essentially, there are so many issues. So essentially, when you really do an assessment of solar power system technology for installation, it really requires a tremendous amount of engineering knowledge, not in one discipline, but other disciplines. My goodness, if you are doing this, let's say, a 1 megawatt or 2 megawatt, 3 megawatt system, you're no longer looking at just environmental issues. You're looking at power being generated at thousands of amps. There becomes a major issue about safety, security, shortages. There are thousands of fires that are caused in the United States and abroad. Nobody cares about them. So essentially, how do you really prevent the system from really going through that? Essentially, if you go on a rooftop, for example, it's a big, huge roof. You cannot put solar power system and have the conduits because buildings move. If you have what they call an expansion joint, you have to have very special technology to take care of it. If the building expands, if you have bridges and so forth, you see they have these chasms that allows building expansion and contraction due to heat and so forth. So you really have to be totally aware of the physics of the building, the structure. How do you bring the power from the roof down to where the power distribution is? How do you connect the system to the metering system? So essentially, residential systems are like comparing a bicycle to a nuclear power plant. Everybody understands bicycle, okay? So everybody goes in the bicycle business, but not too many people go into nuclear power. Why? Because they don't understand. So the issue today is, how do you segregate the engineering aspects of really treating or segregating between what is it that is being requested by the client to design? So if the guy says, I want a 10 kilowatt system, I say, why don't you go and talk to the neighbor who's done a 10 kilowatts installation? When you come and say 100 kilowatt, okay, then it becomes like, all right, this is a system that needs consideration because you're talking about, you know, at least 100 to 150 amps of power. And so there are issues associated with safety, security. For God's sake, Armenia is a tremor land. You have places like Spitak, thousands of people perishing. Can you tell me I cannot install a solar power in Spitak or Gurmi or other places, even in Yerevan? You have a fault line here. Now, how do you design a system that is integrated, designed in such a fashion that is capable of detecting tremors and shuts itself down? That's the technology that I have invented.
I agree with you. I'm thinking, because I don't know much the details that you do, etc., I've been thinking simplistically, not from a urban application, but a rural. And from a rural application, I've been dreaming about, I have friends who are building hothouses by Sahmana Merz, which is dangerous, etc. They come from their fields and they have to build hothouses and whatnot. To make those hothouses, is there a way of designing some solar paneling or helping there to increase their year-long utilization, cut on their electricity? They don't have electricity bill. You know, I'm thinking on a very, very simplistic way of how solar energy could apply to be it in Karabakh, be it in the Lori system, region, etc., to hothouses where villages are striving to grow something and for us to be helpful. I don't know, but it's just a dreaming.
You know, 10, 15 years ago, I met a gentleman who was very interested in solar power. He's a dear friend of mine. He was manufacturing these giant systems, and he wanted to look at the prospect. I told him, so-and-so, that's not good for Armenia. What Armenia needs is a distributed solar power system, small systems in villages, where you could create electrification, especially at the borders, have water pumping, and also provide power with some storage capability for schools and so forth. People at the villages today, at the rural village, they have 1 or 2 cows, they're barely subsisting, and they're not even considered as being part of the major population. So that is really my concern. My concern is, yeah, you want to go and install a 20 megawatt system? For what? Where? You put a solar power system, let's say at a distance, 200 kilometers from Yerevan, that power is going to be lost. What are you going to be doing with that lost power? Why not take that 100 megawatt and have 30 villages electrified? Now, that is really